Hello everyone. So today we're going to go over the Chapter 6 review. As you can see here, this used to be an old quiz. So we're going to make an answer key for this quiz today. All right, so let's look at some questions. We are looking at two graphs, one on the left, one on the right. And it says which one might represent a polynomial function. Now, if you look at the function on the left, that is most likely going to be a polynomial function. In fact, you can pretty much guess that this is going to be a cubic function. Um, what you notice is that two important properties, although it doesn't guarantee you're going to have a polynomial function, but all polynomial functions are smooth and continuous. Now, it doesn't mean that if you have a smooth and continuous function, that is automatically a polynomial. But if you see a function that's not smooth or not continuous, then it's definitely not a polynomial function. All right. So on the right, the function on the right, that is not going to be a polynomial. And the reason why is because even though it is continuous, it has sharp corners at -3, well, actually it's negative pi, 0, and then here pi. And what that means is that it has yeah, sharp corners, so it's not a polynomial. Okay, and that's it. So next up, we are going to look at um, the most important features of polynomial function that we talked about in class. So on the left, we have a horizontal line. That's going to be a constant. So this actually has equation y equals to -3. So clearly this is degree 0. There's no leading coefficient because the variable doesn't, the variable x doesn't show up anywhere. And the constant term is the y-intercept. So the y-intercept is -3. So that is what we have. All right, so the function on the right, you can see that it is a parabola. So, and it's facing downwards. So this is certainly going to be degree 2, quadratic. Because of the fact that it's pointing down or opening downwards, the leading coefficient is going to be negative. And finally, the constant term, again, that is the y-intercept. So in this case, it is going to be 2. Okay. So next up, we are going to do kind of the same thing, but without graphs, just with the functions, or just the equations themselves. On the first one, we have f of x equal to x squared plus 2x plus 1. You are also given the vertex here, -1, 0. So let's see what we can do here. Now, since the vertex is on the x-axis, that is to say the turning point is on the x-axis. That means the function only has one x-intercept. Although this is a degree 2 polynomial, as you can see here, x squared. So it is possible for it to have 0, 1, or 2. Depending on what kind of quadratic we're dealing with. Okay, but in this case, it's clearly 1 because the vertex is on the x-axis. The y-intercept is just going to be the constant term, so that's going to be 1. Okay. The domain, since this is a polynomial function, it's going to be x is an element of all real numbers. This is true for all polynomials. All right, the range, in this case, you're given the vertex, so you know exactly what the turning point is, and it opens up, so it has a minimum value. We know that this parabola opens upwards because it has a positive leading coefficient. So it's going to look like this shape. All right, so the range will be y is greater than or equal to 0. Okay. The end behavior, again, if you saw the sketch earlier, it's going to draw slightly more. You have a parabola, has a vertex of -1, 0, has a y-intercept of 1, so it's going to look kind of like this. You can see that comes from quadrant 2 and ends in quadrant 1. So 2 to 1. And the vertex is the turning point, so it has 1 turning point. Okay. Next up, we have a cubic function. So with cubic function, it's a little bit harder to tell the possible number of x-intercepts. In this case, it does just have 1, but really the only way to find out is to either use a table of values or use something to graph with like a graphing calculator or Desmos. Okay, so it is possible to have 1, 2, or 3. It has at least 1 x-intercept. We'll talk about y in just a bit. Now the y-intercept will be -7 because that's what the constant is. It's right here. We also have the domain is going to be x is an element of the real numbers. Now the range, it is a odd degree function, so the range is going to be y is an element of the real numbers as well. The end behavior, now this is a negative function, so it's going to go diagonally across the plane this way. So it's going to come from quadrant 2 and end in quadrant 4. Okay, and now this other part is hard to tell as well, unless you draw a graph of it, the number of turning points. This particular cubic function has 2 turning points, but the possible answer are really just 0 or 2. Okay. This next part, so sometimes what we can also be asked is to kind of draw a polynomial that fits the description. So in this case, it says extends from quadrant 2 to 4. It shouldn't say 4 to 2. Generally, you want to be moving from left to right. So let's quickly change that. Okay, 2 to 4 has 2 turning points and a y-intercept of 0. So one possible way to draw this is here's the y-intercept of 0. Here's a turning point. It ends in quadrant 4, as you can see, and then we can draw another turning point in quadrant 3 and have it go up into quadrant 2. So that would satisfy the conditions. Next up, the range is less than or equal to 2, so this is going to be a quadratic function for us. So here's 2. X-intercepts of 1 and 3, so let's just go with 1 here on the left and 3 on the right. And you can draw the vertex right at y equals 2, and it will be a parabola that opens downwards. All right, so this is the part of the chapter that's about the properties of polynomial function. Of course, the second half is about polynomial and regression, so let's look at that. Quick example here. We have some data in table, x and y. So in this case, has been plotted for us already. So here's a scatter plot of that data. If you look at the question, the first part asks for use the cubic regression feature on a calculator, determine the cubic function. All right, so on Desmos, recall that we start a new item, so item number 2. So y underscore 1 tilde and then ax underscore 1 to the third power, because it is going to be cubic, plus bx underscore 1 squared plus cx underscore 1 plus d. because for a cubic function you have four parameters: the one that's cubic, the one that's quadratic, the one that's linear, and finally the constant. So we need to find all four of them, and we have the parameters a, b, c, and d. All right, so the first thing you want to do here is to record them. It says 3 decimal places, but the first parameter is a little bit too small, so I'm just going to write the answer this way here. So y equals to negative 0.00234 x cubed plus 0.178 x squared minus 5.275x plus 301. All right, so that is now on record. It says here, use the cubic regression equation to determine the value of x when y is equal to 90. So we go back to Desmos. We simply let y equals to 90. That will produce a horizontal line, and we just look for the intercept between the curve, the cubic regression equation, and then the straight line. So x is going to be equal to 7.758. So we let simply let y equal 90, and then x will be 7.758. All right, so next up, we are going to use a linear regression instead. So similar to what we just did, but linear regression to determine the it should say linear, sorry, not linear. All right, that models the data, so very similar. So let's go back to Desmos. Can make a new line for this: y underscore 1 tilde ax underscore 1 plus b. All right, so go ahead and change the color here. Actually, maybe like that, so we can see it better. So you can see this is the line of best fit. Some of the points are pretty far below it, and some of the points on the right are pretty high above where the line is. But we do have parameters now, a and b. Let's write those down here. If we use a linear regression instead of a cubic one, we get y equals to negative 1.805x plus 109.864. Okay, and finally, use the linear regression to determine the value of x, y equal 90. So it's the same horizontal line, so we did that part already. So we're looking for this intersect right here, and it turns out x will be 11.002. So same thing, y equals 90, then x is equal to 11.002. It's pretty far off from what we got before. It says which model appears to be better for the data. So if you go back to the graph, you can see that the curve has much smaller errors all the way through. So the cubic regression is better because it has smaller errors. Okay, so it is a better fit. All right, so that's pretty much the content of this chapter. Again, it's two halves. The first half was about the properties and characteristics of polynomial function, and the second half is about how to use regression for linear, quadratic, and cubic functions if you're given some data, and how do you choose which kind of curve or line to produce. Okay, so that's it for today. Thank you for listening.